We're going to do a little bit of practice with translations from ordinary language into symbolic logic notation for quantifier logic. More specifically, we'll do a bit of practice that involves material from Chapter 9 of Language, Proof, and Logic. So on the left side of the Tarski's World pane, you've got a world. You can see that we've got cubes, tets, and dodecs. The only object named is the tet. And then on your right hand side in the right pane, you've got a series of sentences. So what we want to do is practice translating, and we're going to use the world to help us understand what it is that the sentence says so that we get an accurate translation. Now, don't forget the 4 Aristotelian forms that serve as the translation foundation. That is, each of the forms is the translation foundation for universal affirmative, universal negative, particular affirmative, and particular negative sentences. Right, so number 1, every cube is large. So we're talking about a universal. Why? Because every, along with all and any and so forth, is an ordinary language word that expresses the universal quantifier. So we're going to assert for every thing, so for every x, if that thing is a cube, then that thing is large. And we have our parentheses around the entirety of the phrasing that by itself, that is unbound by a quantifier, would not be an actual sentence, so we would not have a well-formed formula. So we're saying that all things cube are large. Now remember, the standard translation of the copula are, that is the conjugation of the verb to be, for universal claims is the arrow. And we can tell whether or not the sentence is true by seeing if the world satisfies it. So let's look at the world. We have a couple of cubes. One is large, but the other is small. So we would say the sentence is false because there is at least one cube that is not large. Next, the sentence, no cube is small or medium. Now, we've got 3 predicates, right? We've got our subject, class, cube, which becomes a predicate term. And then we have the predicates small and medium. So that means that on the right side of our arrow, we have the predicates small and medium, and then we have the disjunction because we have a return to our propositional logic notation, more specifically our Boolean connective, the disjunction. So for every thing, if the thing is a cube, then it's not the case that it is either small or medium. And notice when I'm speaking here, I'm talking about, or I'm using language like it, right? But that's just a way of articulating a grammatical sentence in ordinary language. Recall that the reality here is we're talking about everything cube and entities small, entity medium. So we're not talking about a specific number like 1, 2, 3, and so forth. Notice also that we have parentheses around the entire phrase so that we have marked the scope of our quantifier. And we also have parentheses around the disjunction so that we are clear that the negation covers that disjunction. One way that we can read the sentence back, that is, read out the translated sentences as follows. For every x, if it's a cube, then it's not the case that it is small or medium. Once again, we can check whether or not the sentence is true by seeing whether or not the world satisfies this sentence. Now, is it the case that there is at least one cube that is small or medium? And the answer is yes. So we would not say that it's true no cube is small or medium, because there is at least one cube that is medium. Sentence 3 says, it is not the case that there is even one small cube. Let's start by noticing that the sentence is a negation of an existential. You might read it, however, as a universal. In other words, you might say nothing is a small cube. And that's perfectly fine, because remember, we have equivalences between existentials and universals. But what we want to try to do, at least at the beginning, is to translate as literally as possible. So let's start with our two atomic elements. We have entity small, entity cube. And the sentence before it's negated says that there is at least one small cube. At least that's how I'm verbalizing what the sentence says. The sentence says there is even one small cube, but that's not entirely grammatical. At the very least, it's not colloquial. We would say instead there is one small cube. So in that case, we say there is something, the thing is small, and the thing is a cube. And then remember that we've got a negation at the front. It's not the case that there is at least one thing that is small and a cube. Now, if we were to push the negation through, we would change the quantifier. So we would get this sentence. Hold on, I'm just going to copy paste. So we would get universal negation, and this sentence would say, everything is not a small cube. That is, everything is not both small and a cube. Now, through the process of demorganization and taught con, we would get the following. So I'm going to copy. If we push the negation through by De Morgan's, right, we get either not small or not a cube, and then a taut con is going to change the disjunction to a conditional. The negation drops off the left side of the conditional, that is the antecedent, and notice what we get. We get the standard universal negation. So these two sentences, nothing is a small cube, is equivalent to, it's not the case that there is one thing, at least one thing rather, that is a small cube. Sentence 4 reads, there is at least one dodeck. So now let's go ahead and translate in the order of the ordinary language sentence. So we get the following, there is at least one thing the thing is a dodeck. So here we get an atomic sentence, right? Why is it an atomic sentence? Because there is no connective involved, right? We don't have any one of our Boolean connectives. We don't have the material conditional. We don't have the biconditional. Sentence 5 says, at least one object is not a cube. Again, let's translate in order here. There is at least one thing, existential X, and it's not the case that the X is a cube. Not every dodeck is small. Now let's return to what we were talking about in exercise 3, where there are times when we want to, depending on what our intellectual habits are, what we want to do is to take the sentence that is a negation of a universal and translate it as an existential, right? So not every dodeck is small. We typically think of in terms of if we do this thing, if we have this habit, to say that there is at least one dodeck that is not small. In other words, some dodecks are not small. But let's go ahead first and translate by negating the universal, as the sentence asserts, not every. It is not the case that every. And then we have our standard translation, dodeck X, conditional small x. So let's read that translation back. It is not the case that for every thing dodeck, that dodeck is small, or it is not the case that for every x, if x is a dodeck, x is small. Now, let's talk about the equivalence between the universal and the existential. So the negation is pushed through and the universal becomes an existential. Now, for right now, we leave everything else the same, right? Why? Because the only change that we've made is from the negated universal to an existential with the negation on the other side that is on the right side of the existential. Everything else has been left untouched. It's not until we begin to work on the connectives, the operators, that we'll begin to see the standard existential negation. So our first taught con move, which in some versions of the system we're learning is called implication, has us take a conditional and replace the conditional with a disjunction and add a negation to the left side of the disjunction, that is to the left disjunct. Now you can see the De Morgan's move that we make. The negation is pushed through the parenthetical. So we have a negation on each side of the connective that becomes the conjunction. And then these two negations on the left side of the conjunction, that is on the left conjunct, are eliminated. So we get there is something, or there is at least one thing that is a dodeck but not small. So you see the equivalence now to the standard existential translation. Number 7 reads as follows: it is not the case that there aren't any tets. Well, let's go back to our original strategies for translating compound sentences and begin with the simplest parts. So we're talking about what things? Tetrahedra. So we're going to have the tet predicate and a variable. I'm just using x all throughout as our placeholder. As we build out, we see the phrase, there aren't any. So depending on how you interpret this phrase, you'll get a universal or an existential. In other words, remember we've talked about what your sort of intellectual habits are. Mine, for example, would be to say it's not the case that there is at least one, but it may be the case that you might write everything is not, right? So let's stay in keeping with the literal. So any is a universal. So we would say universal X negation, tet X. Everything is not a tet, which is another way of saying there aren't any tets. Then at the beginning of the sentence, we have the negation. It's not the case that. So the negation goes in front of the universal. So we can go ahead and read back in. It's not the case that everything is not. We can also think about the alternate translation of the phrase, there aren't any, right? And we could say, it's not the case that there is even one, right? But we'd still have to have our negation out front. It's not the case that. So that gives us two negations in front of the existential. Now, when you go back to your equivalence, right, between the universals and the existentials, you'll see that a negation on each side of the universal is equivalent to an affirmed existential. And you know, truth functionally, two negations are equivalent to an affirmation. So we can move from this universal to this existential. Now the last three exercises involve the one object that has a name. And I've included these because we want to remember that when we name an entity, we are not going to, depending on what's going on with the quantified part of the sentence, we're not going to leave that that named entity unbound. So let's go ahead and start with our tet named A. And we know that we know that there is a cube. The cube is unnamed, and the article A is not a universal. I hope, understand that we're talking about an unnamed cube, but still a specific cube, right? So we're saying that there is something, that thing is a cube. We've already got our tet A. We know that our standard translation for the existential is the conjunction, right? So there is something, that thing is a cube, and that thing is to the left of the tet named A. So in this case, just for the ease of reading, I'm going to put the tet named A last. So we get the following. There is something, that thing is a cube. Oops, sorry, two conjunctions there. So let me start again. There is something, that thing is a cube, and that thing is to the left of A, and A is a tet. Now you could, because there's no problem with a logical equivalence here, you could move the sentence A is a tet to the position, to the immediate right of the first conjunction. So I could just as easily,
translate this way, right? So there is something, the thing is a cube, and A is a tet, and the thing is to the left of A. The point here that I think is more important than the order of where the tet named A goes in the sentence is the fact that the entire sentence, right, has parentheses around it that show us the scope of the quantifier. Why do we bind effectively the constant A? Well, only because we need to bind this variable x. If we don't bind the variable x, we don't have a well-formed formula. So the binding of the A, if you will, by the parentheses that tell us what the scope of the existential is accidental. Okay, so now let's see this in action again with the next sentence, a small to the left of the tet named A. So there is something, it is small, it is dodeck, it is left of A, and A is a tet. Remember, when you have a series of conjunctions, you don't need to separate them out with parentheses, but remember that you do need to bind your variables to the quantifier, in this case an existential. Notice that just real quick in terms of translation tips, the article A can implicitly refer to a universal, it can implicitly refer to an existential. Why do I say implicitly? Well, the context of the sentence, our understanding of what the sentence is after, is what tells us whether or not we use a universal or an existential. So think about it this way. If we say something like a dodeck is a shape, or a dodeck is a geometrical figure, then we're talking about any dodeck, right? Here, we're talking about a specific cube. All right, lastly, we've got a universal, right? No cube is to the right of the tet named A. Now, remember our standard translation of the universal negative. Universal, parentheses, conditional, negation on the right side of the conditional, close parentheses. What are we talking about? We're talking about cubes and that which is to the right of the tet named A. So we've got right of A and tet A, close parentheses. Don't forget, though, we've got to make sure that we specify the main connective here, right? We've got a conditional, a negation, a conjunction. Well, remember, we're negating what is on the right side of the conditional, so we need parentheses around the entirety of this sentence. Now, let's read back to make sure that the translation is correct. For everything x, if x is a cube, then it's not the case that it is to the right of A and A is a tet. Now you might ask, why the conjunction? Why not, for example, a disjunction? Well, let's break the sentence down. I'm going to pretend as though what's highlighted in green is not here. Let's just read as much as we can, given that when we do not account for the universal, we have an unbound variable, and so we don't have a well-formed formula that is a syntactically correct or in this case, meaningful sentence. We get the following: it's not the case that entity is right of A and A is a tet. What if we said neither? Well, we would be rejecting the claim that A is a tet we would also be saying that it's not the case that that entity is right of A. So we don't want to make that sort of claim. So the conjunction, if we were to push the negation through, would say either it's not the case that entity right of A, or it's not the case that A is attacked. On the other hand, if we have a disjunction in place of the conjunction, when we push the negation through, we would be rejecting each, and that would be false. Okay, so now let's do this. Let us remember what our ordinary language sentences are, and let's see if we have correct translations for each. Now, we should get a T for each one of our translations. Please note that that by itself does not guarantee that our translation is correct. Why is that? Because we could get a T for an accidentally correct translation. And let me rephrase that. We could get a T when it's not the case that the translation is an accurate one of a literal translation of the sentence in ordinary language, yet the notated sentence, that is the logically notated sentence, still comports with the world that we have, right? That said, however, it still is a good first step to seeing how your translations go. One of the reasons why our textbook has as many exercises involving comparing worlds is because we don't want just an accidentally true sentence, that is a sentence that is true in the world, but a sentence that is true in the world because the translation is correct. Okay, so what I'm doing here is I'm just I'm eliminating all of the ordinary language sentences. I'm also eliminating the alternative translations. Okay, so I'm going to hit the R verify button, and we should get sentences that come out true and come out false where they should. So why is it that 1 and 2 come out false? Well, remember, the original sentence in 1 says that every cube is large, and we said earlier that that's not the case. We also said that it's not the case that that every single cube is not medium or small. I hope this practice is helpful to you as you build your understanding of the basics of quantifier logic.